Lavoisier laid the foundation of chemical sciences by establishing two important laws of chemical combination. And these laws were established after much experimentations by Lavoisier and Proust. It is the law of conservation of mass and the law of constant proportions. Law of conservation of mass states that mass can neither be created nor be destroyed in a chemical reaction. This means that during a chemical reaction, the sum of the masses of the reactants and the products remain unchanged. We can confirm this by doing a simple activity. Take some sodium sulfate solution in a conical flask and some calcium chloride solution in an ignition tube. Hang the ignition tube in the flask by a thread and put a cork on the flask. Find the mass of the flask on a balance. Then tilt the flask. A chemical reaction takes place and sodium chloride and calcium sulfate are formed. Then find the mass of the flask again. It will be seen that the sum of the masses of the reactants and the products remain unchanged. Law of constant proportions, that's the second law, which states that in a chemical substance, the elements are always present in a definite proportion by mass. For example, in a compound such as water, the ratio of mass of hydrogen to the mass of oxygen is always 1:8, whatever the source of water is. Thus, if 9 gram of water is decomposed, 1 gram of hydrogen and 8 gram of oxygen are always obtained. Similarly, in ammonia, nitrogen and hydrogen are always present in the ratio 14:3 by mass, whatever the method or the source from which it is obtained. The next problem faced by scientists was to give appropriate explanations of these laws. British chemist John Dalton provided the basic theory about the nature of matter, and his theory was based on the laws of chemical combination. According to Dalton's atomic theory, all matter, whether an element, a compound, or a mixture, is composed of small particles called atoms. The postulates of this theory may be stated as follows. All matter is made up of very tiny particles called atoms. Atoms are indivisible particles which cannot be created or destroyed in a chemical reaction. Thirdly, atoms of a given element are identical in mass and chemical properties. Atoms of different elements have different masses and chemical properties. Atoms combine in the ratio of small whole numbers to form compounds, and the relative number and kinds of atoms are constant in a given compound. So what is an atom? Have you ever observed a mason building walls, from these walls a room and then a collection of rooms to form a building? What is the building block of huge buildings? And what about the building block of an anthill? It is a small grain of sand. Similarly, the building blocks of all matter are atoms. An atom is the smallest particle of an element that may or may not exist independently and retains all its chemical properties. Atoms are very small in size and smaller than anything we can imagine or compare with. For example, the atomic radius of an atom of hydrogen is 10 raised to minus 10 meter, and the radius of a molecule of water is just 10 raised to minus 9 meter. So now let's see the modern day symbols of atoms of different elements. In the beginning, the names of elements were derived from the name of the place where they were found for the first time. For example, the name of copper was taken from Cyprus. Some names were taken from specific colors. For example, gold was taken from the English word meaning yellow. Nowadays, IUPAC, that is the International Union of Pure and Applied Chemistry, approves the names of elements. Many of the symbols are the first one or two letters of the element's name in English. The first letter of a symbol is always written as a capital letter and the second letter as a lowercase. For example, hydrogen has the symbol capital H. Aluminum is capital A with a small l and not capital A with a capital L. And there you can see some symbols of some common elements. The most remarkable concept that Dalton's atomic theory proposed was that of the atomic mass. Since atoms are very small in size, its mass is very small and determining its mass is very difficult. So the mass of an atom is compared with the mass of a standard atom. The atom which is considered as a standard atom for comparing the masses of other atoms is carbon-12 atom, whose atomic mass is 12U, where U is called as the atomic mass unit. So 1 atomic mass unit is the mass of 1/12 the mass of carbon-12 atom, and the atomic mass of an element is defined as the average mass of one atom of the element compared with 1/12 the mass of a carbon-12 atom. There you can see the atomic masses of a few elements. Atoms of most elements are not able to exist independently. They usually form molecules and ions. These molecules or ions aggregate in large numbers to form the matter that we can see, feel, and touch. So what is a molecule? A molecule is in general a group of two or more atoms that are chemically bonded together. That is, tightly held together by attractive forces. A molecule can be defined as the smallest particle of an element or a compound that is capable of an independent existence and shows all the properties of that substance. Atoms of the same element or of different elements can join together to form molecules. The molecules of an element are constituted by the same type of atoms. Molecules of many elements such as argon, helium, etc. are made up of only one atom of that element. But this is not the case with most of the non-metals. For example, a molecule of oxygen consists of two atoms of oxygen, and hence it is known as a diatomic molecule, and it exists as O2. If three atoms of oxygen unite into a molecule, instead of the usual two, we get ozone. The number of atoms constituting a molecule is known as its atomicity. Molecule of a compound contains atoms of two or more different types of elements. For example, in water, which is a compound, the combining elements are hydrogen and oxygen in the ratio 2:1 to form H2O. Now let's see what an ion is. Compounds composed of metals and nonmetals contain charged particles, and the charged species are known as ions. An ion can be negatively or positively charged. A negatively charged ion is called as an anion, and the positively charged ion is called as a cation. Take for example sodium chloride, that is NaCl. Its constituent particles are positively charged sodium ions, which is Na plus ions, and the negatively charged chloride ions, which is Cl minus ions. So to conclude, the two laws of chemical combination are the law of conservation of mass and the law of constant proportions. And we also discussed the basic theory about the nature of matter proposed by John Dalton, who introduced atoms and molecules. And remember, atoms also exist as charged particles called ions.